Okay, starting back from the beginning, just a little brief overview of some of the notation and what you're being asked to do. This notation here means we're taking the inverse, which means we're asking this question: where does the fill in the blank equal whatever's inside the parentheses? So you look it up on your unit circle, you look up this in the coordinate pair, or if it's tangent, you should have marked them on the outside, hopefully, or you'll have to figure it out, y over x. And then you give your answers, x equals. So then we look down here, if it's when it's written like this in number 3b, we're given the tangent of x equals pi over 3. This is just the step before something like in 3a, where we take the inverse tangent of both sides. This is what this notation tells us. Taking the inverse tangent crosses out the tangent, leaving us with x equal to this. And we do the same thing, look this up, and here's our answer. So moving on, number 4c had us looking at rationalizing. I guess technically you should really multiply by 2 root 3 in the top and the bottom, but it'll all cancel out in the end. This little shortcut here. Basically, you should just be able to recognize that this rationalizes into this. You might not memorize it, but once you start getting through this process, you should recognize the end. Just about everything that we're doing in this unit is on the unit circle, or is a tangent of something on the unit circle. So that should be your big clue whether or not you've done it correctly. Why do we need to rationalize these? Because sometimes you're going to get reciprocals. Like if you look in part D here, we're going to be taking reciprocals, and if you have something like this down here, we need to rationalize it so it looks more familiar. So as you see here, I've worked out two different ways. I have a long way and I have a short way. The long way involves doing a little bit more algebra. And so we change the cotangent into 1 over tangent, and then I multiply both sides by tan of x, divide by negative root 3, rationalize, then look this up on the unit circle, and here I get my final answer. Short way is a shortcut. Yay, shortcut. So we take cotangent, change it to 1 over tangent, and then you take the reciprocal of both sides. So I take the reciprocal of 1 over tangent, that leaves me with tangent, and I take the reciprocal of this, which, with some rationalizations from over here, we can rewrite like this, and then this should be something that's written on your unit circle already, inverse tangent of negative root 3 over 3. We get the same answers as we did in the other section, so it's a nice little way of checking our work. So that leads us to a case like this where we're going to solve an equation with secant in it. First, I'm going to get secant x by itself, so I need to isolate the trig. And then we take the reciprocal of both sides. And once I get the reciprocal of both sides, I know that the cosine of x is equal to 1/2. Take the inverse, and we get our final answer here. Down here in 2f, a little bit different. This is the one where you were told to simplify first. So by simplifying, we see a lot of things cancel out. This sign cancels with this. Notice that for cotangent right here, I changed it to cosine over sine because if we had written it the other way, that didn't really help me simplify, so we don't want to do that. I want to use cosine over sine. You might have to do a little trial and error, but this way we simplify down to 2 cosine of x. Both cosines cancel out over here, left with 1. Then we isolate. Then we take the we didn't need to take the reciprocal, but we did need to take the inverse. And finally, we get our answers here, pi over 3 and 5 pi over 3. Moving right along in part G, we're looking at things that were either undefined or no solution. Tangent is undefined at pi over 2 and 3 pi over 2. Since tangent is y over x, when x is 0, we get undefined. So x is 0 at those 2 points. Cotangent is x over y, so when y is 0, then we will get undefined. And then this one down here, I'm just putting out the two that were no solution. There were two other answers here that did have solutions. Basically, something that you should realize here is that sine and cosine can't be bigger than 1. So they could go down to -1 as well, but so they should be between -1 and 1. But if you see something like 3 or, well, 3 in both of these cases, 2, 5, any of those numbers, we get no solution. This one I had to take the reciprocal of both sides first before I could see that. And once we see the reciprocal of both sides, I see that we're trying to take the inverse cosine of 3, and we get no solution. Just something to look out for. In this example here at the bottom, 3i, we are getting into the factoring portion. These ones, this is already in factored form. We just had to set both pieces equal to 0 and then solve. So first off, isolate. Then in this case, we took the reciprocal and then the inverse. Over here, this one was easiest. We just had to take the inverse. Okay, here 4J, this one is not in factored form, so first make sure everything is set equal to 0. Then we're going to take out the greatest common factor, which in this case both terms had a cosine. Then set both equal to 0. And then go through the whole process. First isolate, and then take the inverse if you don't need to take the reciprocal. And over here, it just needed the inverse. 3k is another factoring example, but in 3k we have 3 terms here. We have a trinomial. And in a trinomial, it's helpful to use something called U substitution. U substitution is just a way for us to rewrite something in a way that looks a little bit more familiar. So we take everything, instead of writing cosine, we turn it into a u. So we get 2u squared plus u minus 1 equals 0. If it's not equal to 0, make sure you do that. That's the first step. First thing that I did to factor this, you can do guess and check and some other methods. I took the 2 and I multiplied it by -1, and I got -2. And then I was looking for factors that would add up to +1. So 2 times -1 equals -2. 2 plus -1 equals +1. So factors of -2 that add up to +1. Then I split it up, so I have 2u squared plus 2u minus u minus 1. Split it down the middle, so we could do factoring by grouping. Take a 2u out over here, and take a -1 out of here. The goal is to get both of these pieces to match, so I could regroup here at the final step, and then rewrite with cosine. Because now at this point I'm ready to go back and set both equal to 0, isolate, and take the reciprocal. I had to do that on both sides this time because both sides had a second term. So both of these factors were binomials, unlike in 4J when only one of them was a binomial. Last set that I'm going to review here is when we have, this is a function in a function. In this case, you'll see a little bit more obviously we have 2x inside the sign. You know that we actually have an identity for this one, but you don't need it in this case. So what we do here is, these are the same problems. This one is that 1m is just a step beyond where 1n is. First, take care of this side over here. First, do the inverse sign. Then divide by 2. So looking down here at 1n, I need to get the 2x from outside of the sign, so that's why I take the inverse sign of both sides. So then I'm left with 2x equals the inverse sign of 1/2, which I know has 2 answers. Now the solution is the same as above. 2x equals 5 pi over 6 or pi over 6, so I need to divide both of these by 2, which, if I take 5 pi over 6 divided by 2, this is written up here, by the way, 5 pi 6 divided by 2 is the same as 5 pi over 6 times 1/2, and that's where the 12 comes from. Works the same on the second fraction.